Okay. So go ahead and get your notes out. We're gonna skip a few things. We're gonna be, great question. We're before the BFFs. And I think we're gonna do 9 and 5. We're gonna skip 3 and 4. We did 1 and 2, yes. So yesterday, I think we finished all of 1 and 2 for 1.2. We're gonna skip 3, we're gonna skip 4, we are gonna do 5, and we're gonna do 9 because that's what your homework is on.
We have homework tonight?
I'm gonna give you homework tonight.
Thanks.
Lock in, great point.
No, I have to give it a break for him.
Okay, we're gonna be nice to each other. We'll give them a little bit of crap for not listening, but now we'll say, okay, now we're good. We're done giving you this.
That was with that. I love you kids. No.
Now, what we're gonna learn today are 2 things. We're gonna talk about asymptotes, and we're gonna talk about domain. Okay, I believe these are things that you've maybe talked about before. But again, I always like to treat things like you've never seen it. So first, when we're gonna talk about domain, remind me, what does that mean? What are we worried about? All of our X values. So think about like, what can I plug in? Okay, if you can plug in positives and negatives and decimals, great. I'm gonna say that there's 2 things that we're gonna have to worry about. Okay, there's gonna be 2 rules that we're gonna have to worry about, and we're gonna talk about them when we get to them. Okay, if I look at 5a, is there any problem with any X to plug into X squared plus 4? Can I plug any number into X squared plus 4? Can you square positive? Can we do positive number squared? Can we do negative number squared? Can we do zeros? Can we do decimals? All of those are fine. So we're gonna say all reals, negative infinity to positive infinity. Okay, that's just an example of a normal one. So it's okay to have all real numbers work. If you remember our BFFs, most of them. Oh, that might be bad news. Okay, that's gonna be a later issue. If you remember, domains actually are often all real numbers, okay? Now, if you look at letter B, we have our first problem. What's the problem with letter B? Where are we gonna have an issue? The denominator, right? The X on the bottom. What can the denominator not equal?
0.
It cannot equal 0. And in this case, if I say X minus 3 cannot equal 0, then that means X cannot equal 3. Okay, that is not, oh, sorry, what? The denominator, if it equals 0, if we have like 5 divided by 0, that's not a real number. Remember, in the slopes, that's undefined. So that would give us a vertical asymptote, which we're actually going to get into after we finish with domain. So if you have 0, we can't graph that. There's no points there. So my domain here is everything except for 3. Okay, I don't want this written in this form though. I want it in interval notation. So let's do a little number line off to the side. I care about 3, and I just can't be 3. I can be anything less than 3. I can be anything bigger than 3. I just can't actually be 3. How would I do my interval notation for that? Good. Yeah, perfect. Good job. Notice that I've got parentheses here, no brackets, because I cannot include 3. We're going to parentheses every time we see that, okay? So that's actually my first rule. I told you there are 2 rules. The first one is denominator cannot equal 0. So if you have a denominator, we need to make sure that it is set not equal to 0. Okay. So if I look at the one next to it, let's do that. Letter C, it says 1 over X plus 2 over X minus 3. The first denominator that we can't have, the first number X can't be is what?
0.
0, good. X cannot be 0. What about the second denominator? What can X also not be? 3, good. So X cannot be 0 and X cannot be 3. So let's draw a number line again to make sure that we visualize what's happening. Now, do you need to draw a number line? No. Do I find it helpful? Yes. So I'm going to draw it because it helps me. If it does not help you, don't do it. I will argue though, if I like put this on quizzes and tests and you can't get the domain right and you don't draw a number line, I'm going to tell you maybe you should draw a number line now. Okay, what would my interval here be? Good, negative infinity to 0. 0 to 3, good, and 3 to infinity, good. The most common thing here is that we miss that 0 to 3, okay? We often know 0 to, or negative infinity to 0 and 3 to infinity, but we often forget that 0 to 3. The only thing that it can't be is 0 or 3, but anything between those two numbers is totally fine. Okay. Let's actually skip D and E for 1 second, because that adds something new. Let's look at F and G, because those are still denominator problems. So we set the denominator not equal to 0. If that's the case, what will my x's not be equal to? 2 and not 8, not 3, -2. We add 4 to both sides, so it becomes x squared cannot equal 4. And when you square root both sides, remember that +2 can be squared to be 4, but also -2 can be squared to be 4. So you need to think about a plus or minus in front of that when you square root. Okay, same idea, let's number line. Can't be -2, can't be +2, we can be literally anything else. What's my interval here?
-2.
Uh-huh. Good. Every single one of these have been parentheses because we cannot actually include those points. We do unions between all of them, and we've gotten every space. We just don't have -2, we don't have +2. All right, last one like this, and then we're gonna add the last rule, okay? So this one, my denominator, I'm gonna set not equal to 0. When I start solving it though, I get x squared cannot equal -4. When we square root both sides, what's the square root of -4? I, it's got i's involved. It's going to be plus or minus 2i. Can I draw a number line and put 2i on my number line? No. I is imaginary. It's not a real number. So I'm going to say my domain here is all reals because the only problem that I have is a number that's not a real number. So every single real number works here. Negative infinity to positive infinity. Okay. Let's go back to those two that I skipped. Okay, they still have the denominators that we care about. Okay, so let's look at D. Let's do the same thing that we did. Let's do our denominators. Okay, so we cannot equal 0. I know that it looks like there's a lot going on there, but you can set each of those separately not equal to 0. So I'm going to set x plus 1 is not equal to 0, and I'll do x squared plus 1 is not equal to 0. What numbers are going to be not equal to 0? Not x cannot equal here. -1. What about from the other one? Anything? 1i. Can I put that on the number line? Does that matter to me? I'm gonna just, I can even cross them out. You didn't even have to write them in the first place. The only thing that the denominator cannot be is -1. Okay. Now, the numerator poses a bit of a different issue here. The only reason that I separated these two out is these numerators have radicals and none of the other numerators did. Okay. Do you remember what a square root function looks like from your BFFs? Not a problem, that's an x squared one.
Square root, oh, it's like a line.
It's like a line, right? It's like a sideways parabola. It starts here at 0, 0, and then it extends off, okay? So that means that it can't be any negative numbers. It's only positive numbers. You can only put positives in here. There's no negatives in our domain. So when I have a radical, my rule for radicals is it must be greater than or equal to 0. It cannot make it negative. So I'm going to set my radicals must be greater than or equal to 0. You can ignore the actual radical, you just care about what's underneath the radical. So I'm going to take this first one, it says 4 minus x. I'm going to make that greater than or equal to 0. So 4 minus x is greater than or equal to 0. All right, let's solve that. I think the easiest way to do it is to just add x to the other side. So 4 is greater than or equal to x. If you're anything like me, that doesn't really mean anything to me. So instead, I'm going to just flip it. So the x is first. So I'll say x is less than or equal to 4. Okay. Now in this problem, I have two issues now. I've got two things to watch out for. Not just x can't be these two numbers. I have x can't be -1 and x must be less than or equal to 4. Okay, so I'm gonna graph both of those. Bless you, I was waiting for you to sneeze. And then you stop. Well, sneeze stage fright. I need to make sure both of those things are true, so I'm gonna go graph them on a number line. I really do think a number line is helpful here. If you don't think you need it other places, fine. I do think this is helpful. I care about -1 and I care about 4. Okay, I cannot equal -1, so I just have an open circle at -1. I can be anywhere else. 4, I need to be less than or equal to. So I'm gonna do a closed circle on 4, and I'm gonna go less than or equal to. When I write my interval notation here, I want where both the green and the purple are. I want here and here. I don't want anything bigger than 4 because that's not true under my radical. I can't have anything bigger than 4. I only want numbers that are true for both of them, okay? So the first part of my interval is gonna be what?
Negative.
Awesome. And then what's the second part of my interval? Good. Bracket, very good. Why is there a bracket there? There's a full circle. It's an or equal to, it's what? I think you're right. I just didn't hear you. Okay. You're probably right. I just was talking over you. I just didn't hear you. It's a full, see how I did a solid point there, not an open circle. So that is why it's a bracket. All right, we're gonna do the same thing for the last one.
Where's that one?
Yeah.
We were like, why didn't we put did we put a bracket on it?
We only have put a bracket on the 4. We haven't put a bracket anywhere else. The reason,
I thought we did because we did like at a point, like on the graph, there's like at a point, like points.
good, it's because they're open circles at the point and they're not closed circles. Mhm. All right, this last one, let's look at letter E, okay? Let's do the denominator first. What can x not equal? X will not equal, I think +2. And then we have to set that the radical greater than or equal to 0. So x plus 3 is going to be greater than or equal to 0. So x is going to be greater than or equal to -3. Oh, sorry, what? Oh, okay, same thing here. Let's draw a number line where I graph both x is not equal to 2 and x is greater than or equal to -3. -3 and 2. Greater than or equal to -3. Okay. Again, I only care about the part that's both green and purple. So here and then here. What am I gonna write for my interval? Mm-hmm. Good. Bracket or parentheses with -3? What about 2? Good, and then
2.
all parentheses, very good. -3 to 2, bracket with the -3, and then 2 to infinity. Okay, so that is domain. How are you feeling about domain? Okay. Last thing I want to cover, I want you to skip down to number 9. We are going to do asymptotes, okay? Now, I believe you guys did asymptotes back in algebra 2. I'm going to reteach it, but I'm going to kind of hope that you guys have bring a little bit of prior knowledge, okay? When we do asymptotes, do you remember which BFF graph that goes with? Which one goes with? The funny one? That one does have asymptotes. We're going to go with the reciprocal. Why am I not spelling that right? Reciprocal. There we go. That was really hard for some reason. Reciprocal function. So that means it's a fraction. Okay, we're gonna have a numerator. We're gonna have a denominator. Okay, so I'm gonna do my vertical asymptotes over here. I'm gonna do my horizontal asymptotes over here, and we'll do all of our vertical asymptotes first. Does anyone remember how we find vertical asymptotes? What'd you say?
Do the vertical one side.
We could do that, but when we just don't have a picture, we have just a graph, or we have just an equation. Elena? No. That's gonna be your horizontal asymptote. Vertical asymptote is a lot like domain. We are going to set the denominator equal to 0. This time, we're not gonna set it not equal to 0, we're gonna set it equal to 0 because I want to know where would there be a number that's not in the domain. That's your vertical asymptote, okay? So for this first one, we're gonna set x plus 1 equal to 0, -1. X equals -1. What about letter B? Good. Ooh, letter C is a little bit of a tricky one.
Negative
Mm-mm,
1.
mm-mm,
Might just be X.
mm-mm, not 0. Is there a denominator here? Technically, it's 1, right? If I set that equal to 0, can I like solve that? Nope, there just is none. That's a quadratic. There are no vertical or horizontal asymptotes for quadratics. So it has to be set up like a fraction. What about letter D? Plus or minus what? It'd be plus or minus I, right? Can we put I on my graph? Nope, anytime you get I's, there's just no vertical asymptote. What about letter E? Also none. Letter F? -3. And then, ooh, gee, we gotta do a little factoring. X minus 4, x minus 1. So x is equal to 1 and 4. Good. So that's a good example. You can do 2 of them. Okay, last one is horizontal asymptote, which Alea, you already kind of alluded to, but I want to remind you that there are 3 different ways that we do horizontal asymptotes because we care about the exponents on top and bottom. Okay. The first way is that the exponent on bottom is bigger than the one on top. If that's the case, your horizontal asymptote is just y equals 0. Which is what a normal reciprocal graph is, it's just normally at 0. If it's the same on top and bottom, then you look at the coefficients and you make a fraction of those coefficients. So it's going to be, like in this case, it would be 1. I like to just write coefficients in front to remind myself that it's not always something you have to look at your example, whatever the 2 leading coefficients are. And the third one we'll actually deal with more later. It's if my exponent on top is bigger than the one on bottom. We call that slant asymptote. For today, just identify it as slant. In the future, we'll actually figure out what that slant asymptote is. Okay, so your answers are 0, a fraction of the coefficients, or slant. Or as always, none. What is letter A gonna be? Nope, let's look at the exponents. What's the exponent on top?
Is it coefficient?
It's just 1x. How many x's are on the bottom? Just 1. They're the same exponent, so we're gonna make a fraction of the coefficient. It's just 1 on top and 1 on bottom, so my horizontal asymptote is 1. Does that feel familiar? Maybe yes, no? Okay. What about the second one? What do we got there? What is it gonna be, sorry? 2. They're the same, so it's just gonna be y equals 2.
But how do you get to?
Because there's an x on top and an x on bottom, so their exponents are the same. And if they're the same, then we look at their coefficients. What about the letter C? Is there a top and a bottom? Nope, so what do we say? None. What about letter D? We're not, oh yeah, we're gonna say 0. I almost got confused for a second. What about the next one? 1, very good. The exponents again are the same on top and bottom. So we're gonna just use a fraction of the coefficients. What about letter F? That one's gonna be a slant. See how I've got a square on top and just a normal one on bottom? That one's a slant. And then last one, letter G, what do we got there? 1, very good, y equals 1. That should at least be somewhat of a review, and so 1.2 homework is due next class, which is on Tuesday. If this was a little too fast and you need to talk about it again, I got office hours on Monday, okay? There, we didn't finish 1, 2, but I still want you to do that homework because everything else is not on your homework. I'll figure that out next class. I think, no, we go to G period, and then we go to core, and then we go to lunch. Sorry, say that one more time.